In this video, we are going to see about the CAD for additive manufacturing. So CAD is the abbreviation of computer drawing or drafting. So CAD model, you can see in the slide on the left hand side, you can see the CAD model, that is the cup, and you can see the right hand side, it is split into different kind of elements. So this is nothing but the STL file format. STL stands for Standard Translated Language. So this is how the data is fed into the 3D printer. So the 3D printer always uses the STL file format in order to print the required product. So this is about the difference about the layer thickness. So you can see the top, the first image, that is the CAD model, and the second and third, that is the bottom images, shows how the layer thickness is involved in the finishing the product. You can see the surface finish of the product. The first image, that is in this image, you can see how the layers are visible in the product, and the finishing is somewhat rough when comparatively to the right hand side of image. This image, you can see the product that is somewhat smooth, and it's still the layers are visible. So this is nothing but because of the layer thickness. So in the 3D printing machine, you have to give minimum thickness, that is say 1 mm or 0.5 mm. Likewise, we have to give the layer thickness in order to achieve the better quality. Also the printing at speed. So these are the things that involved in the finishing of the product. So other than these, the CAD model can be created, and the other technologies that are used are, the first is the reverse engineering. So the reverse engineering is directly opposite. That means normally in conventional engineering process, the designer will design a component, and the designed component is then manufactured according to the requirement. Whereas in reverse engineering, the product is redesigned. That means the product is scanned using different techniques, and then the CAD model is created, and then it is modified, and then it is produced. So that process is called reverse engineering. The process is reverse in nature. So that is why it is called reverse engineering. Next is the computer aided engineering technique. Computer aided engineering is nothing but the designing and analysis package, because normally what we will do is we will design and we will manufacture, or else we will do reverse engineering. Here computer engineering, we will design a product, then we will virtually, that is perform some analysis, for example thermal analysis, using some engineering packages that are analysis software, such as ANSYS, Nastron, Hypermesh, Abacus, etc., etc. So these software helps us to see how the product is suitable for our required application. So this is how the analysis is done, and according to the analysis report, and the product is modified according requirement, and it is then manufactured. So this reduces the first copy cost, that is the prototype cost is reduced, and then the special machines or the special process involved in the production of the first product, and then it is tested. Everything is reduced by using this analysis process. So the haptic is the another technique. You can see the visualize the technique how it is used in the slide. So difference between various additive manufacturing technique. In the previous slide, we have seen about the different types of process, that is a solid, liquid, and powder based process. So all these process, there are the common difference. They are the technique used for creating a layer. In solid based, we will use the laser in order to solidify the layer. So the powder based material are heated and fused by the application of laser, that is powder based. Then in the liquid based process, again a laser is used to scan the layer. So each layer is scanned. So the liquid based material is converted into the solid based material. And in the solid based additive manufacturing process, the material is laid layer by layer by means of a nozzle which melts the material into the semi-solid or the liquid form, and then it lays the material layer by layer. So this is how the technique used for creating layer by layer. Next is the technique of bonding the layers together. In some process, for example, for bonding and all, binder jet machining, there is a process called binder jet manufacturing. So in binder jet manufacturing, yeah, additive material is used. An external material is agent is used to bond the two different layers. So the powder based material is fused or bonded by means of the external agent. So this is what the bonding of the layers. Next is the speed. So the nozzle speed. So the print head speed also one of the factor. So that is also one of the difference between the different AM techniques. Then is the layer thickness. Layer thickness means what is the layer thickness? 1 mm, 2 mm or 5 mm. What is the layer thickness? According to the process, it may be varied. Next is the range of material. So in the powder based process, we can use materials in the wide range. That is, we can use metallic materials or we can use non-metallic materials. Whereas in the liquid based, we can use the resin based materials only. Then the accuracy. So accuracy is very much important. How precise the component is required. That is important in choosing the AM technique. And then the cost involved in a few processes such as resin based process, the cost is very cheap, whereas in the metallic part the printing cost is high. So you have to choose according to the application and then the requirements. So this slide shows how the additive manufacturing is evolved in the starting from the year 1988 and now the year 2024. You can see the first of all it is named as rapid prototyping. So rapid prototyping is a process where we will manufacture the first copy of the product and then we will test the product and then we will go for manufacturing. That is rapid prototyping. And the rapid casting is similar process where in the foundry the first casting is melt. Similarly, rapid tooling in the year 1995. Rapid tooling is the first tool before going for the bulk manufacturing. So now in the year 2001, this technique is used for automobile, because in the automobile we will use many products, many components in the vehicles. Then they went for aerospace applications. Then the year 2004. Then it is evolved and then they started to build aerospace metals such as titanium. And in the year 2013-16, they started manufacturing nanomaterials. And by the year 2013 to 2024, we can see here the application of 3D printing is having a next gen, that is they have started printing full body organ, for example heart, lungs. So these kind of organs can be printed using biomaterial and they can be replaced into the human body, so that the parts can be functioning as like the natural parts. So this is how the technology is evolved nowadays. Some advantages and disadvantages of additive manufacturing. The advantages of the additive manufacturing is the green manufacturing, mainly green manufacturing. That is, there is no wastage in the material. The material is built layer by layer. And the disadvantage, whereas with respect to green manufacturing, is that inconsistent material. You cannot choose the right material, because in conventional manufacturing there is no constraint in choosing the material, because you can choose wide range of manufacturing process and you can start manufacturing. Whereas in additive manufacturing, only selective materials can be used in the selective process. And the additive manufacturing also requires skillful labor, where he or she is able to perform design and the printing operations, operate the machine, and the knowledge is very much important. Whereas in the conventional manufacturing, there is no need of highly skillful labor, because the CNC machines and all, just a program can run the machine and it can manufacture the product. So you can see the things here. So the difference is the tooling here is not required, whereas the in conventional manufacturing tooling is required. So here the precision can be in additive manufacturing can have precise components, whereas in conventional manufacturing precision components is very difficult, and it requires high cost and high machining processes involved. And in the additive manufacturing, you can see personalized components can be manufactured, whereas here in the conventional manufacturing, it is difficult to produce personalized manufacturing or personalized components. So that's it about today's class, and we will meet in the